Hi, this is Mr. Max with Sankofa Mathematics. I am now starting with my series on doing the paper ones of the AS level. So I'm starting with paper 1, grade 12, that was written last year, 2 hours long. Okay, right. As per usual, I always would advise you that you always make sure that you are reading through the instructions and the information that you're given, and especially when you working with degree of accuracy, and if it's not really specified in the question, and also if the answer is not exact, then you will give as a default the answer to three significant figures. But when you work with angle sizes in degrees, you give to one decimal place, but angles in radians you also can give to three significant figures. Now, often with this type of papers, you would definitely also hear or see that the STEM say that you must give your answer as an exact value. So in those cases, it's either you give your answer in terms of pi or a root of something or fraction or some e raised to a certain power. So just make sure that you read the questions carefully. Let's start with the first one. They are saying by substituting k is equal to 3 to the power x or otherwise, so you don't really necessarily have to use that, and there should be another option, but we're going to stick with what the instruction says. So we need to solve this equation. So the first thing is that you are supposed to be familiar with is what I would like to call the split rule. So basically you can write this as 3 raised to the power of 2x times, I'm going to put a dot for the multiplication, 3 raised to the power 1. Because when the bases are the same and you multiply, you add the indices, and surely that is what's going to happen over there. Okay, so let's just then go ahead and write the other stuff as they are given. Plus 9 is equal to 0. I'm just going to do a little bit switching here of the exponents. So this is going to be, I'm going to write it here. This is going to be, perhaps I can just do this. This is going to be 3 raised to the power of x. All right. So, and then I'm going to have that square. So that's basically this one, because you are going to multiply these any case, so it's going to give you the same answer. And I'm going to put this 3 in front over here. Okay. And then I have minus 28, and then I'm going to put in the brackets here, just in the color black, the 3 raised to the power of x. Right, so this is like a hidden quadratic. So when we decide that this 3 to the power x should be equal to k, then this is going to be 3k squared minus 28k plus 9, that is equal to 0. Okay, right, so this is a quadratic that you should be able to factorize. Okay, or if you want to, you can use the quadratic equation formula. Okay, but at this stage, as an AS level student, I am expecting that you should be able to solve this using the method of factorization. Right, so if you multiply out these factors to give you 0, it implies that either 3k minus 1, 3k minus 1 is equal to 0, or it implies that k minus 9 is equal to 0. So this is going to give you the values of k as 1/3, or k is equal to 9. But we're not looking for k, we are looking for 3 raised to the power of x. So we have to definitely replace that k with 3 raised to the power of x. So this then becomes 3 raised to the power of x, and I'm just going to rewrite this as 3 raised to the power of negative 1, because that's what it means, or 3 raised to the power of x, and I'm going to write this 9 as 3 squared. So if the bases are the same, then you can just go ahead and equate the indices. So in this case, x is equal to negative 1, or x is equal to 2. And these are going to be the solutions that you were expected to find. And also, you have to take note that they say solve the equation. So you need to find both those roots. Right, let's go to the second question. It says given that ax to the power 4 plus 9x cubed minus x squared plus bx plus 8 is identical to all that stuff that is there. Find the values of a, b, c, and d. All right, so what I'm going to do is I'm going to work on the right hand side. That means I'm going to take the bracket of x squared plus 3x minus 4, and I'm going to multiply it out with 2x squared plus cx plus d, and I will see what this is going to give me. So I'm doing the right hand side. So if I were to multiply these out, I'm just going to get 2x to the power 4 plus cx cube. Right, so I'm first multiplying each of the terms in the second bracket by x squared, and then x squared times d, that is going to be plus dx squared. Right, then I'm going to take the 3x and multiply it with each of the terms in the second bracket. That is going to give you plus 6x cubed, that is 3x times 2x squared. Then 3x times cx is going to be plus 3cx squared, very important. And then I'm going to have the 3x multiplied with d, and that is going to be plus 3dx. Now the last one that I'm going to multiply out would be the negative 4, and I'm going to multiply the negative 4 over each one of those terms. Okay, and I might be running out of space here, but let's see. So that's going to be negative 8 x squared, that is this times that. All right, and then when you continue, you're going to have a negative 4cx minus 4cx. Let's see if we can squeeze it on, and then if you multiply negative 4 times d, that gives you negative 4d. All right, so let's go ahead then and write the terms so that we can have the coefficients. So 2x to the power 4 is pretty much on its own. But what I will have here is that I will have the term, the terms that contain my cube. I'm going to have cx, no, not x, so let's just take the coefficient. So we take c plus 6. These terms, they contain the x cube. You can just check. So I'm taking their coefficient, the c over here plus the 6. Once I'm now done with that, I'm going to now take the terms that contain the x squares, right? So let's look at the terms that contain the x squares. That is going to be this d that has the x square plus 3c, and then there's another one minus 8. Minus 8. All these terms have the coefficient of x squared. Okay, right, and then I'm going to obviously now look at, because I'm not done with my x squared, so I'm going to look at my terms that contain my x. So this is going to be the x coefficient is 3d, which is over here, minus 4c. Can you see that? So that's minus 4c. So all of this, they have then the coefficient of x. And then what I'm going to do lastly is just have the negative 4d. That's the constant term. So what we're going to do now is we are going to equate the coefficients. Right. So once, if I look at that a and 2, so that implies that a is equal to 2. Okay, and then if I look at the c plus 6, this is going to equal, and very easily you can see, is going to equal to 9. So that equals to 9. And the next one that I'm going to look at is the d plus 3c minus 8, and this should equal to the term that contains x squared, and the term that contains x squared over here, well, that is negative 1. So this should equal to negative 1. And lastly, also I'm going to take 3d minus 4c, this term that have got the x, and that is equal to b. So that is going to equal to b. So I'm just going to let that equal to b. All right, and then there's one more thing. I'm going to take the coefficient, in this case negative 4d, which is this one, and I'm going to let that equal to this constant because this one represents the constant. So we can now actually look at all these equations and we can solve them. Right, I can even solve this equation here for d, and if you solve this equation for d, this will imply that d is equal to negative 2. Okay, so that is one value. And then what else do I have? So when we are now looking at, so we have this value over here, we have our a, we have our d, no problems asked. Okay, so we know what is d. We can actually calculate this equation over here. So I'm just going to write that equation. So that equation is d, just write it in blue. So it's d plus 3c minus 8 is equal to negative 1. This is d minus 8. Okay, in fact, let us just take away that. It's a d plus 3c is equal to negative 1 plus 8. That is the same as 8 minus 1. That is going to give you 7. But we have the value of d from here. So we know that d is equal to negative 2. So negative 2 plus 3c is equal to 7. All right. So this should give me that the value of, so I'm going to write it here. 3c is equal to 7 plus 2, which is 9. Therefore, c is equal to 3. Now, I have the value of c as well. Okay, I have the value of c. So let's see what is it that we can calculate again. Right, we can calculate also these ones here. This one, the 3d minus 4c, which equals to b, because I know what the value of d is. D is nothing but negative 2. I know what the value of c is. C is nothing but 3, and this should give me all the value of b. Right, so this is negative 6 minus 12, and that is negative 18. So now I also know what is the value of b. So I have my a value, I have my b value, and I have my c value. Anything that I have left out? In fact, we could even have calculated c very easily from here. You know, if you were to find c here, you would realize that c is equal to 3. No need also then to. Okay, so I have my 4 unknowns that I'm supposed to get, so I can just as well go ahead and just write my final answer then. So I'm going to say um, what I have now is a is equal to 2. All right, so therefore a is equal to 2, b is equal to negative 18, c is equal to 3, and d is equal to negative 2. So all of this are my solutions, what they were asking us to find. Right, many ways you can do this, but I think this is the best way by looking at those coefficients. Just have to be a bit careful, especially if you now select those coefficients, that you do not make a mistake. All right, let's go then to the third question. And the third question is something that has to deal with binomial expansion. They say in this expansion of the quantity 2x minus 3 over x all raised to the power of 6, find the term independent of x. Now, if the term is independent of x, if that is the case, if the term is independent of x, then it means that this term is the constant term. Okay, it's the constant term. That's what independent of x really mean. The constant term in terms of x will be something of x raised to the power of 0. Okay, because the power of x will equal to 0. That's what we're going to have. Right, so the way you do this, you're going to say the r plus 1 term, all right, that is going to be, I'm going to have my 3 brackets. That's what I'm going to have. Right, Now you know the formula. So I've got 6r is what I do not know. Then this is going to be the value of a 2x, and this is going to be minus 3 over x. All right. And then here I'm going to have 6 minus r, and this one I'm going to have r. Okay. So let us just then go ahead um, and work on this one. So what is it that I now know? So remember, I'm particularly interested in the terms of x, so I'm just going to separate them. So 6 choose r, and then I have got 2, then 2 should be 6 minus r, and I have got x 6 minus r, and then over here I'm going to have negative 3 to the power of r, and of course the other bracket is going to be x to the power negative 1. All right, let's just make sure that it's at least written nicely. X raised to the power of negative 1, and this is to the power of r. Okay, so I'm really, as I said, only interested because 6 choose r and 2 raised to the 6 minus r and negative 3 to the r. These are all constants. I'm not really interested in the constant. I want the terms in terms the ones in terms of x. So I'm going to say, let's then look at the term x 6 minus r, which is this one, and this one here multiplied by x to the negative r. And we're going to let that equal to x raised to the power of 0. That's what we're going to do. Okay, so when now you look at the left hand side, when you multiply and the bases are the same, you add. So this is going to be 6 minus 2r, and this is going to equal to 0. Now, if you were to solve this for r, you'll get that r is equal to 3. Now, this is going to help us for us to find the term independent. So now I'm going to take only the terms, the constant terms. So I'm going to take only this. Now that I know what r is, I'm only going to take this and I'm going to take this. These are what the terms that I'm going to use now. So I'm going to say, hence, the term independent of x, okay, a constant term, the term independent of x is equal to, I'm just going to write it under here, will be equal to, now that we know what r is, so it's going to equal to 6 choose 3, okay, multiplied by 2, 6 minus 3 to that power, multiplied by 3, it's negative 3 rather, negative 3 raised to the power of r, which is 3. And then we can go ahead and obviously calculate what this is, right? Okay, so 6 choose r, you can obviously use your calculator. You have 6 choose 3, that's a value, that's 20. And this is 2 raised to the power of 3, which is 8. So I'm going to multiply that by 8. And then I'm going to multiply, this is negative 27. That's what you're going to get when you, times, when you raise that to negative 27. That is negative 3 cubed is negative 27. And you have 4,320. And that it's negative 4,320. Okay, and that is the term that would have a coefficient of that is the constant term where x is raised to the power of 0. That's what we are looking for there. All right, you might have a different way of calculating it. Bottom line is you're still supposed to end up to minus 4,320. That would be the term that is independent of x, or the constant term, the one that does not have an x. Okay, let's go to question 4. A pump is used to extract air from a bottle. The first operation of the pump extracts 145 cubic centimeters. So this has to deal with geometric progression. Okay. And then that 145 is going to be my first term. So I'm going to say A, which is what we're going to use for the first term, is 145. So I also know this is a GP. Very important to take note of it. They say the fourth operation of the pump, so the fourth term, it extracts 74.24. Okay, and the thing that is now going to guide me is that if you know from your formula, the T sub n formula, which is a r raised to power n minus 1, so the fourth term, that implies that the fourth term will be a, which we know is 145, okay, and then because we are now looking for r, that is what they are saying, determine the common ratio, so we are looking for r. So r is unknown, but it will be 4 minus 1, and this is equal to 74.24. So it becomes a very easy operation that we should be able to calculate in order for us to find the value of r. Doing that, that is going to leave me with r cubed is equal to that 74.24 divided by 145. Okay, so you grab your calculator. If you take 74.24 and you divide that by 145, what do we get? 64 over 125. So it's 64 over 125. And if you know, you would know that 64 over 125 is nothing but 4 cubed over 5 cubed, which is the same as 4 over 5 cubed. So if r cubed is equal to 4 over 5 cubed, therefore r is equal to 4 over 5. That is the solution here that we are looking for, because they ask us to find the common ratio. Okay, clear. I hope that everything is clear, even if my working look a little bit, I don't know, jungled up, but I'm explaining, and I hope that it is assisting you. All right, just write that 74 very nice over here. So that is 74.24. Okay, this question in itself has a B part. In which operation does the pump first extract less than? So this is an inequality that you are going to form, all right? Less than. So what this is going to imply, it's AR to the n minus 1 should be less than 10. But we know from before our A value is 145. Now we also know that R is 4 over 5, okay? And then we are looking for N. And here's the thing, when you look for N, it will imply that we will be using logs over here, all right, or exponential equations, because we are looking for something that is unknown that is within the exponent. All right, so first thing also, we are first going to divide both sides by 145. So that's going to be 4 over 5 raised to the power of n minus 1 is 10 divided by 145. Okay, so if you look at 10 divided by 145, just to clean that up, so I have 10 over 145. What does that give me? 2 over 29. Okay, right. So I have 4 over 5. You could also write this as a decimal of 0.8. Doesn't really matter now. And then this is 2 over 29. Now, we are going to take logs both sides. I'm going to take the log of 4 over 5 raised to the power n minus 1, and then I'm going to take the log of 2 over 29. Right, so using the power law, obviously the n minus 1 comes in front, and then you have log of 4 over 5 is less than log of 2 over 29. Now here's something very interesting. Because I need to get rid of this by dividing here by log 4 over 5, and I'll also have to divide here by log 4 over 5. But a very interesting point that I want to bring is that when you have a log of a fraction, okay, and the fraction should obviously be greater than 0. The fraction should be greater than 0, should not be negative, okay? So if for example, if you have log of a half or log of a third, all these answers will be negative, and you can have a look. You're always going to have a negative answer, so positive fraction. So because of that, essentially it means you're dividing by a negative number. And because you do that, this inequality sign should reverse. So this is going to leave you with n minus 1. I'm going to change the inequality sign around. Okay, so you can just go ahead and check again. So if you say log of 4 over 5, you would see that that will give me a negative number. And whenever you're dealing with inequalities, when you are dividing throughout by negative, in order for the inequality to remain true, the sign has to reverse. Right, so I'm just going to write down what this decimal value is. So I'm going to have the log of 2 over 29. Okay, and that should be divided by the log of 4 over 5. So I know already, but then here's the thing, the one on top is also a fraction, so essentially you're dividing a negative number by a negative number, and you should get a positive number. All right, because when you look for n, we cannot be looking at or getting negative values. So that's like 11.3.9 something, 9839. So it's about 11.984. So that's 11.984, for example. So this implies that n would be greater than 12.984. The 12 is, I'm adding 1 to both sides. But then what is the number? Because you are looking for a value. That implies what number is greater than 12.9. Therefore, n is equal to 13. Okay, so that is the solution that we are looking for over there. All right, so quite a lot that deals in that question, but definitely found the answer. So just be careful whenever you are working with logs and you are dividing by a negative, the inequality sign reverses. So that brings me to part C of the question. Now they are saying if the pump continues extracting the air indefinitely, and the word indefinitely I can put infinite. And then I'm looking at another hint, and is the word total amount. So that's sum to, this is sum to infinity. Okay, sum to infinity. And hopefully you should know the formula for sum to infinity. It's a over 1 minus r. So they are now asking, we need to find that value. So what do we know? We know from before that our value of a is 145. We also know that our r is equal to 4 over 5. So this is just a matter of us punching that into the calculator. And if you do that, you're going to get 725. And that is the solution. Okay, right. Let's then go and start with question 5. Question 5 says, find the set of values. And whenever you are asked to find a set of values, a range of values, you are dealing with an inequality. You'll be dealing with inequalities for which the constant h for which the equation has no real roots. And the equation, remember the discriminant, which is b squared minus 4ac, if there are no real roots, then that is going to be less than 0. So that is a very important concept. But what I'm going to do is I'm first going to say, let's find what the discriminant is. Our value of b here is minus 3h squared minus 4. Our value of a is 1. No need for me to write it. Okay. And but I will write it anyway. Our value of c is going to be nothing but what? Our value of it's going to be nothing but h. So what does this give me? This is 9h squared minus 4h. All right. So let's suppose now this is less than 0. That's what we are looking at. Okay. Now, in terms of a graphic representation, you would know that a graphic representation will imply if this is the x-axis, okay, if this is the x-axis, and this graph is going to open up like so. Okay, so when this whole function is less than 0, it means it's negative. So we are looking at this range. That's what we are looking at. So essentially what I can do is I can say this is a value of something and this is a value of something, and I will be calculating those values. So what I will look, I'll call those values critical values. So for those critical values of a and b, I'm going to let this 9h squared minus 4h equal to 0. So I can treat it as an equation and find what my values of a is. But I know my answer will be a range that is between a and b. Okay, so definitely what I mean by that is that I know that the solution that I'm going to look for eventually will be given as and if I have to write it over here, will be given as x in the middle, and my a value will be there and my b value will be there. So this is what I would know what I'm going to look for, because that yellow part below the function. Right. If you were now to sort of factorize this h is common, then I have 9h minus 4, which equals to 0. And if I then find my two values, this is going to be h is equal to 0, or 9h minus 4 is equal to 0. In such case, h would equal to 4 upon 9. So now that I know what my two values of a are, and then I will say, okay, that implies that my solution will be h will be between 4 over 9 and 0. And this is the range of values that I'm looking for within that as required in the question. Okay, so that is 5a. Then 5b now they say, in the case where h is equal to -2, right? So what do I know from before? I know from before that delta was equal to 9h squared minus 4h, right? But now they're saying h is equal to -2, so that implies that I have 9 times -2 squared minus 4 times -2. Determine the number of real roots, so we need to see what the discriminant will be, and you will realize that this answer is equal to 44. And when the discriminant is equal to 44, the discriminant is greater than 0. That's what you can see. Then it means there will be two roots, two distinct roots. All right, that is what that implies. The roots will be 2. The number of roots will be 2. Can I say 2 real roots? Okay, let's just write the word distinct nicely. All right, keyword, how many roots? They're going to be 2. Okay, so that is part B of that question. Now we are going to part question 6, and they say a function f is such that f of x is equal to 2x squared minus 12x plus 14. And let us see, they say express this in terms of invertex form, a in bracket x plus p all squared plus q, where the values of a, p, and q are constants. So let's see. First off, I'm going to start by saying the 2. I'm going to take out the 2 between these two terms over here. So I'm going to have 2, then I have x squared minus 12 minus 12x. No, it's not minus 12 now, but it's x squared minus 6. Okay, minus 6x, and then plus 14. And then if you know, using completing the square, you know, you take half of this term and you square it. So I'm going to have 2, and then I'm going to have x minus 3 all squared. That's what's going to happen here. Now here's the thing, if you have to multiply this out, this whole bracket, it will give you x squared minus 3 minus 6x plus 9. So there's a 9 in there, so I'm going to take away the 9. Okay, very important that you understand that concept. And then obviously plus 14. So if I have to reiterate that on the side, if you have something like x minus 3 all squared, it becomes x squared minus 6x plus 9. So the part that I was trying to show you, we had this part, which was this part over here. So there is a 9 that's added. That is why I am subtracting that 9 over there. Okay. So let's see what that gives me. So first of all, I want to multiply out by 2. So that's going to be 2. Then I have x minus 3 all squared. And then 2 times negative 9, that is negative 18 plus 14. Now you can just clean it up a little bit more. So that's 2x minus 3 all squared minus 4. Right, so we can actually go ahead and write the values. A is equal to 2, and then my P is equal to negative 3, and then also, and Q is equal to negative 4. Can actually do that as well. So, and treat those as the solutions that we're looking for. All right. Now, they say find the range of f of x in the domain there. Now, maybe I would be explaining this concept um, a little bit when I consider something. First of all, the vertex formula tells us a few things. This inside, the turning point is going to be the opposite of this, which is 3, comma, negative 4. So this is the turning point of this graph. If this graph has to be drawn, right, however you draw that graph, the turning point, this is the TP that we are talking about. But now here's what the question is asking. What is the range of this graph going to be? So if I have to use a sketch, and I'll be punching that in for you to see what that implies, or maybe before I even look at GeoGebra. Okay, I'll come back to GeoGebra. So what it means, um, if you take putting 0 into the function, and the function f of x, I can also, this is f of x. F of x is in vertex form. It can also be 2x minus 3 all squared minus 4, or you can write f of x equals to, as they were giving to you in the beginning, which is this whole 2x squared minus 12x plus 14. It's the same thing. It's just different format of writing it. Okay, so that's 2x squared minus 12x, what is that? Minus 14. We'll just rewrite that nicely. So it's just different ways of writing 2x squared minus 12x minus 14. But I'm going to use the first one. So I'm going to take, when f is 0, what is the output? And here's the nice thing. This turning point, this is the y value of the turning point. So that is the lowest part of the graph. So I know that is going to be the lowest part of the graph. So if I input 0 and 5 in my function, I am really interested in finding the highest, the range of the graph. So it's going to be like from negative 14 to some negative 14, I say, from negative 4 up to somewhere. So let's see if we input f of 0. So the moment you put f of 0 in here, okay, you're going to get an answer. That is the why the 14 is in my head. And also, when you put f of 5 in here, what are you going to get if you put 5 here? 5 minus 3 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 4, okay, so 8 minus 4, that is going to give you 4. See if I have substituted it correctly. So let's put 5, and you put f of 5. 5 minus 3, 5 minus 3, that's obviously going to be 2. 2 squared is 4. 4 times 2 is 8. 8 minus 4. Okay, this is actually equal to 4. When you put 0, it's not 14. When you put 0, do we get 14? Yes, we get 14. Okay. When we put 5, so 0, that will be 0 here. That's 3 squared, that's 9. 9 times 2 is 18. 18. Hallelujah. That's correct. So I can see what the highest part of the graph will be. It will be at 14. So my range is going to be from y is less than or equal to, is going to be 14, and the lowest part of the graph is negative 4, that turning point there. Okay, that turning point. So this is what we are looking for. And you will surely see if I graph that function, you will see uh, pretty much that. So let me see quickly. If I go to GeoGebra using the software and I punch in the function here, y, let's make that a small letter. So it's y equals to, I'm going to write it as 2x square, okay, 2x square minus 12x minus, oopsie daisy, minus 12x, 2x square minus 12x plus 14. Here is, so we can call it f, right. Um, so this is the graph. So if you look at the graph, can you see that the lowest point of the graph is -4? But what is the range of the graph? But the domain is from 0 to 5, right? So if I really have to look at it, can you see this graph is going to cut the y-axis at 14. So if you input 0, you'll see that the highest point will be 14. But if you input the 5 that you had, that 5, the highest is just going to be 4. But the graph is really from the 0 to 5, the domain, the range of the graph is going to be from 14, which is there, that's the range, all the way until -4. So that's basically pretty much what it means. And take one note also, can you see that the turning point is 3, comma -4 as I indicated. Okay, so that's what that question entails. Now they say another function, ironically this function obviously is the same function, but it has a different, x is less than 3. And then they are asking you, all right, so this function g of x, we know that this function can also be written as, from before, we can also write this as 2, then it was x minus 3 all squared minus 4. Okay, so I'm going to have y equals to 2 x minus 3 all squared minus 4 because they want us to find the inverse. And then I'm going to switch this around. When you want to find the inverse of a quadratic, you need to have it in vertex form. So the objective here is to make y the subject of the formula. So I'm going to have x plus 4 divided by 2. This is going to equal to y minus 3 all squared. To get rid of that square, I must take the square root of both sides. So if I take the square root of x plus 4 over 2, right, is equal to y minus 3. But since x is less than, and this is very important, since x is less than 3, so this is going to be a negative that I'm going to put here. Right, if it was greater than, so that is going to be a negative. So the only thing now that I'm left to do with is to add 3. So when I add 3, this is going to be 3, because it's positive, minus the square root of x plus 4 over 2, okay? And this is equal to the inverse, which is g of x. And this is the solution that we are looking for. This is the solution. There we go. Doesn't matter where you write that g of the inverse of g, right? But that's exactly the way you were supposed to find that expression. Okay. Right, let's go to question 7, or I'll just quickly go back, so give you enough time maybe to just look through that question, as also maybe I'm pausing just to give you the opportunity to take a break. Okay, let's start with question 7. Two circles C sub 1 and C sub 2, these are how they are labeled, they touch each other at point P. Circle C1 has center R and radius 9 centimeter, and circle C2 has center Q and radius 4 centimeter. I'm going to stop there. There's something that I'm seeing. The radius from R to S is 9, which means this is also 9 from R to P. The radius of Q to T is 4, which means from Q to here it's also 4. Right? So I am seeing then a triangle like so. That's what I'm seeing. And this triangle, this is going to be 9 plus 4. 9 plus 4 is 13 centimeters. Then this is going to be 90 degrees, and I am really interested. So what I'm doing with that triangle is here. I'm really doing this. That's what I'm doing. So that what you see is that triangle there. Now, the whole distance is 9. So if this is 4, then the one on top here has to be 5. So I'm going to put my 5 over there. Okay, very interesting that you realize what is it that I'm doing over there. Okay, right. Another thing now with noting, so this triangle is basically the triangle that I have over there. Then they want us to show that angle SRQ, that is this angle over here. That's that angle there, which is going to be this angle, and I'll call it theta. That angle should give you this radians. Since that I have that triangle, right? What I will use, I have a right angle triangle, so I have two sides given. I have a side that is next to this angle that is required, and I have the hypotenuse, so I'm going to find the cosine of theta, and cosine is adjacent, whatever is adjacent to theta over the hypotenuse, and that's what I'm going to use effectively when I'm doing that. Right, so I'm just going to take a whole, all right, so here we go again. I'm going to take a whole, I'm going to close this. We are going to go back and open this up again. And let's see if it restores. Okay. Typically, it normally restores. Okay, so I can actually go ahead. Right, so I did bring that triangle over here. So let's just save this. Okay, and I will just say paper 222. Okay, I'll correct it later. Every time when that happens, I will have to resave and resave. So anyway, so what do we have? We are looking for that angle, so we are using the cosine. So we are going to say that angle theta is going to be the inverse cosine or arc cos of adjacent, which is 5 over 13. And we just have to make sure that our calculator is in radian mode. Okay, so it is already in radian mode, so the inverse cosine of 5 upon 13, all right, let's just close that. You can see that it's equal to the whole lot of that, so it's just going to capture that, and I'm going to bring it over here so that you can see. And if we have that answer, you can see that this answer is 1.176 so on, but to 3 decimal places, right? Therefore, now I have established that, so I will say therefore angle SRQ, this angle is 1.176 radians, and that is 3 decimal places. Okay, right. So that is all that you were supposed to do in that question. Right. Now it has a second part. So what they are now asking, they are now asking us to find the area of that. Now, do you see that ST, the distance S to T, right, is going to be, the distance S to T is going to be exactly the same distance when we're now looking at this dotted line over there. So the way you can find that, you can use Pythagoras. So I'm just going to say, let me paste that, let's rather do this. I'm going to take this whole thing. See if I can just clean this up. Okay. And hopefully nothing again happens. So I'm going to take this whole thing. Let's just take everything that is over there. and then just paste it over here because I don't really want to go back and forth with this. All right. There is something that I'm seeing. All right, first let's calculate what ST is. Now, from that right angle triangle, so if I was to say the distance of ST, which I can write over here, let's say this distance of ST, let's say that distance. So to find ST, I will use Pythagoras, and you are looking for short side, so it's 13 squared minus 5 squared. And therefore ST is going to be the square root of 13 squared minus 5 squared. And S to T will equal to 13 squared is 169. 169 minus 5, that is 144. So therefore the distance ST, this is 12 centimeter. Right. So if you were to look at this, and I'm going to just show you by highlighting it. This here is a trapezium. Can you see that? Right. So whenever you're dealing with a trapezium, the area, I'm going to find the area of the trapezium. So the area of the trapezium, of that trapezium, is always a half times the sum of the parallel sides. The sum of the parallel sides is 9 plus 4 times the height, and the height is 12. That is why we needed to find that 12, because that is like if you take that trapezium and you just flip it around. So this is giving you 78 square centimeter. Why did I do that? If I have the area of the trapezium, now I can actually calculate the area of the sector over here. So I'm going to call that area of sector, and that sector is, I'm going to call it RPS, see, area of sector RPS. Now, hopefully you know the formula. The formula to calculate the area of a sector is, I'm just going to say area of a sector is, the formula to calculate that is a half the angle R squared. Okay, you'll find this in your formula sheet. So I'm going to say half. We have determined what that angle was. Okay, so we know that angle was 1.176 radians times the radius, and the radius for that sector is 9 squared. Right, if you punch this in, you're gonna get 47.628. I'm gonna stop there, 6 centimeter. Then I'm going to find the area of this smaller sector that is over there. So when I look at that sector, I'm going to label it. I'm going to say, now let's find area of sector. That sector, I'm going to label it QPT. QPT. Again, it's a half. And what is this angle? Now, here's the thing about the trapezium. If you know what this angle is in a trapezium, if you know what this angle is, these two angles, they should add up to, because that's 90 degrees and that's 90 degrees. These two angles, they should add up to pi radians or 180 degrees. So whatever this one is going to be pi minus that particular angle. Okay, so I'm going to write here pi minus 1.176. Right, very important that you understand the concept. And then its radius there is 4 squared. Its radius is 4 squared. Again, if you calculate this out, you'll get 15.725. Now, why did I do that? I'm going to take the area of the trapezium and I'm going to subtract this area of the two sectors. So that means I'm going to say the shaded region, therefore, the shaded area of shaded region, okay, area of shaded region is 78, okay, minus the 47.628 plus 15.725. All right. So that's what I'm going to do. Right. So what all of that is going to be my shaded region. And this is giving you 14.647 and so on. And at the end of the day, remember this answer is not exact, so it's just going to be 14.6 centimeter squared, obviously to 3SF. And that is our answer. Okay. Right, so a little bit of work, the diagram. So you see that you obviously have a pencil, and I don't think they are saying to you that nowhere should you have highlighters. The only thing that they say in the instruction, you should not have a red pen. So you can have a highlighter, a yellow highlighter and a green highlighter to help you navigate this, and then you can actually work your method or work your magic and find that answer. Okay, let's go to question 8. Question 8 is very interesting. It deals with coordinate geometry or Euclidean geometry. Depends up to you how you want to call it. Right. They say two perpendicular lines, AC and B, they intersect at M. We are given the coordinates of A and B and C are given, as you can see. Then they say point B is a reflection in the line AC. So the distance that if the B is away from M, that's the same distance that D will be away from M. So if I have to say, I don't know what the coordinates of D would be, but we can write the coordinates of D is going to be X and some Y. Okay. So there are many ways you can look at that question. All right. So what is the first thing? They say find by calculations, find the coordinates of D. So what I will do is I will first find the equation of AC. For me to find the equation, so that's the first thing I'll do. I need to find equation of line AC, which I'm going to write in the form y equals mx plus c. All right. Then know that you have also this to deal with, but I'm going to use this one because I need to be able to see where the two lines are intersecting. Right. So the first imperative thing that is important is for me to calculate the gradient. And the gradient of AC would be take the two y values, you subtract them from each other. So I'll be saying 7 minus 2 over 9 minus negative 6. So that's 9 minus negative 6. So if you calculate this, that's 9 over 15, or is it 9? 5 over 15, which is actually a third. So my equation is taking the shape y equals to 1 over 3x, but I don't know what c is. So I'm going to substitute either point A or point C. Doesn't matter which point you are substituting here. And if I take point A, which is negative 6, 2, and I substitute it in here, so y is 2 and x is negative 6 plus c. So a third of negative 6 is negative 2, and if you go around that, you realize that c is equal to 4. So now I have my equation. My equation AC, the equation AC is actually y equals to, write that for a different color, it's y equals to 1 over 3x plus 4. Very important. Now I'm going to do line BD. So I'm going to do line BD. What I need to know, and very important, the two lines are perpendicular. So the gradient of line BD, will be, if this one is 1 over 3, this one will be negative 3, because the gradient of two perpendicular lines, if you multiply them together, you should get a product of negative 1. So 1 over 3 times negative 3 will give you negative 1. So having that, I can already write my line BD. It can be written as y equals to, the gradient is minus 3x, but I also have a problem. I don't know where that line, that C value is. But I do have point B, which is on that line. So I'll be substituting that point B into my equation. So my point B is the coordinates of my point B is 4, 2. So substituting that 4, 2 here. Y is 2, X is 4 to find my value of C. Then this is negative 12, go there, C will be 14. Okay, so therefore line BD, my line BD is going to be y equals negative 3x plus 14. So these two equations, or these two lines, I'm going to equate them because they will give me the point where they intersect, which is going to be the point M, and that is going to give me the midpoint, or not really the midpoint, so to speak. It can be the midpoint between the two, but the coordinates of M. Once I know the coordinates of M, I can definitely find the coordinates of D. Okay, right, so let's do that. Let's take the two lines and equate them to each other. So I'm going to take negative 3x plus 14. I'm going to say let that equal to, what was the other equation? 1 over 3x plus 4. Right, if you were to work this out, you will see that for you're going to get negative 3x plus, so I'm going to write it over here. So this is going to be 10, that is 14 minus 4. 10 is equal to a third of x plus 3x. Okay, when you're dealing with that, you're going to get a third of x plus 3x. Of course, that is 10 over 3x. So this is 10 equals to 10 over 3x. This is going to give me the value of x is going to be 30 divided by 10. X is 3. Now, the fact that I now know what my x value is, I want to find my corresponding y value, and I can use this equation to find my y value. That is y equals to negative 3, and I'm going to put my value of x as 3 plus 14, and this tells me that y is going to be negative 9 plus 14, which is the same as 5, is it? 14 minus 9. So what is this? This is the value of m, but we're not looking for the value of m. Right, so I'm just going to introduce or insert a page. All right, now let's insert a page or append it just so that I can have space to work with. So I know what the coordinates of m are now. The coordinates of m, they are 3, 5. So I can actually write it here. It's not really a big deal. So that is 3, 5. So I can find the values of D, or the coordinates of D. There are many ways I can do that. One of the ways I can do that, and let's just keep on saving and take a snapshot. Let's take a snapshot of this whole thing, so I don't have to go back and forth, and let's just bring it over here. So one of the ways I can find the coordinates of B, I can say, well, if I know that this is the midpoint, because that's the midpoint, if I add the two x values, that is x plus 4, and I divide it by 2, that should give me the x value of the midpoint. And similarly, if I say y plus 2, this one, so adding the two x values, adding the two y values, dividing it by 2 will give me the mid value, which is 5. I can do that as well, right, to get my d value. So this is x plus 4 is equal to 6. This will be that x is equal to 2, okay, because that's going to be 6 minus 4. This is y plus 2 is equal to 10, that is 2 times 5. Then this is y equals to 8. So what does that now mean? It means that the coordinates of D is 2, 8. But of course, this is not the only way you can find it. You could also take into account that if this is 4 units from here, and you will just be adding x plus 4, that is exactly the same unit. You can find this using many ways. Okay, but to me, I would say let's stick for now with this one. Okay, so the moment something becomes about 5 marks or so, there's quite a lot that you need to do. Okay, let's go to the part 9 or question 9. So you have got two functions, g of x, which is equal to cos of bx, b telling you the period, okay? And then you have another function, f of x, which is a equals to sine x. Something that you should notice is that the a value, right? The a value is going to be, so if this is um, 1, -1, -2, the a value has to be negative. A would be negative, okay? That's what it is. So the sine graph, normally it goes up there. So this whole function is negative because it's now sort of reflected backwards. So a is very clearly seen because they find the value, all right? A is -2. That's what a is. Is it -2 or -3? My goodness gracious. Um, it's over here. It's over here. Where is that value? It's here. It's -3. So a is -3. That's what I'm looking for because it goes all the way up to -3. Can you see that? So that's what that means, the amplitude. So not -2, but rather -3. What else do we now know? Well, B, the cosine graph repeats itself after every 360 degrees. So I'll be saying 360 degrees, but now the cosine graph have got one full oscillation after every 120 degrees. Can you see that? So that is 120, next one 120. So I'm going to divide it by 120, which will make the period equal to 3. That is what you have. A equals to -3 and B is equal to 3. Okay, then they say write down the period of function f. I already spoke about it. It repeats itself after every 360 degrees. So you can write 360 degrees or you can write 2 pi radians. It is not really a problem, but since we are given the domain in degrees, we could have just written 360 degrees. Now, part C is very interesting. Use the diagram to find a range or ranges, okay? A range or ranges of x values for which the product of the two graphs will be greater than 0. So what does it imply? What is greater than 0? Greater than 0 means when you multiply two things, it should give you a positive number. So that's what greater than 0 is. So it's either a positive number times a positive number will be greater than 0. Oh my goodness. All right. Will be greater than 0. When something is greater than 0, it's positive. Or a negative times a negative will give you a positive. What does it mean in terms of graphs? It means we are going to see where these two graphs both above the x-axis, both at the same time, they're above the x-axis because everything is positive, or where are they both below the x-axis? If you look here, this graph here is above the x-axis over there. At the same time, this graph is also above the x-axis. So that is one condition. Both of them are above the x-axis between -30 and 0. So that is one range. So I'm just going to write that one range down. So one is going to be from -30 degrees, okay, to 0 degrees. both of them are, I can say, above. They both are positive above the x-axis. When things are above the x-axis, the functions are positive. Let's see where are both of them below the x-axis. And you can clearly see that if you were to check that where they both below from here, and it's important also that they are saying we should only consider from minus 90 to 90. So we are only doing our consideration from here. We're only considering from here to there. So that is the only part that we're not going to look at anything that is on the other side of this. So where are they now also both below? So they are both below. If you look at nicely from here, this graph up to there, it's below. If you look at this graph from here up to there, okay, both of them are below. The other one is still below, but the other one now here is on top. Can you see that? So it's also then from the range of 30 degrees to 90 degrees. That's basically what you're supposed to look at there. So the other one will be 30, between 30 degrees and 90 degrees. Both are below the x-axis. Both are below. Okay, x-axis. Just leave it there for you to be able to see. But remember, you are only looking at from minus 90 all the way up to 90. So if that minus 90 was not considered, then I would still be considering 150 to 180 because then both of them would be below. But in this case, it would not be considered because we're only supposed to go, our domain only is from restricted from minus 90 to 90 for us to be to answering this question over here. All right, that brings me to question 10. Question 10 is a question on vectors, 3D vectors. And they are saying the diagram shows a rectangular based pyramid, VOABC, as you can see, VOABC. The horizontal base has a length of 12 units and a width of 8 units. The vertex V of the pyramid is vertically above point M, so that is going to be K, all right? And then VM is equal to 40, has got 14 units. The midpoint of BV is N, and then the unit vectors ij and are parallel to OA and OC respectively, and the unit vector k is vertically upwards. Show that AN. So we are now actually looking for, if we are now having to we are looking for from here up to here. How will we go from there up to there? Right. So one way, think of it as a route you can take. We can take A to B and B to N, but we don't have B to N. Okay. All right. So AN can take that particular the way. So what is it that I also can write? So let me write this. A to N is A B plus. But what is Bn? Bn is half of Bv. Okay, so if I can find what Bv is, I can definitely use that to find An. So before I do anything, I will find Vb. Okay, so I'm going to find Vb. And then to go from Vb, I will need a couple of things. I will need to know what is this distance from there to there. Can you see that? And that distance can only be calculated if I use this sort of that base there. So if you look at that triangle nicely, if I want to find MB, because I want to go from V to B. That is what I'm content with. This is what I'm sitting with. I want to go from V to B, so that, I mean, B to V. So I want to find the way I go from B to V. I'm going to go this direction, then I'm going to go up there. Okay, so let me just also write that one down. I'm going B to V. B to V is BM, okay, plus MV. That's what I'm looking for. Right. Can we find BM? Yes, we can. Because if you look nicely at BM, the whole distance there, B to O, okay, because this is going to be halfway. That is going to be, if you go from B to O, I'm going to write that over here. B to O, it's going to be against this, which is minus 8J. You understand that? And then you go against this, which is minus 12J. This is B to O. But I'm looking for BM. So BM will be half of BO. Right? So BV, this is half of BO. That is what this BM represents, plus MV. This one I can write so long. So let me write what BV is then. So BV, I'm going to write here, BV is half of BO, which is minus 8J minus 12, minus 8J minus 12I. Okay, minus 12I. That is BO. What is MV? MV is easy. MV, you can see that you are going up, so that's 14K. Okay, 14 in the K direction. So 14K. So let's clean this up a bit to find what BV is. So BV is half of that. It's minus 4J minus 6I plus 14K. Let me just rewrite it nicely in terms of I, J, and then K. So BV is minus 6I minus 4J plus 14K. Now, why was BV important again? If I come to this, and maybe I can grab it. This is why it's important. And I'm going to just paste it over here, because I'm looking for AN. Okay. So finding my AN then. So I will say that, wait a minute, AN is equal to AB. Now let's go quickly and see what is AB. AB is nothing but 8J. That's what AB is. Okay. 8J plus a half of this answer. A half of this answer. Negative 6I minus 4J plus 14K. If we clean this up, we're going to get 8J minus 3I, okay, half of that plus 7K. Let's just rewrite it nicely in terms of I and J. The answer is minus 3I plus 8J. Is it 8J? Now here's the thing. I need to just quickly, running out of space. Just gonna just quickly redo this one in terms of the brackets. I have got 8J, then a half of 4J, that is minus 2J. So I'm putting my J's together. And a half of that is minus 3I, and a half of that is what? Plus 7K. This at the end of the day is going to give me, but I'm going to write it in terms of I. So it's minus 3I, and then j is 8j minus 2, that is 6j, and then plus 7k. Okay, it was quite a mouthful, but we definitely had to find that, and it wasn't supposed to be as difficult as it appeared, but it's the route that I decided to take to go from A to N. Okay, A to N. Okay, then they say express AC in terms of I and j. Let's see. AC, it's from here all the way up to there. Now AC, you go minus 12i plus 8j. I hope you can see that. Minus 12i plus 8j. So we're going to have minus 12i. It's minus 12i plus 8j. This is AC. All right, just show you that. So you go minus from A all the way to C, it's minus 12i. You're going against this, plus 8 in the j direction. Right, why is that so necessary? They say use the scalar product to find angle AC. Normally, this is what I would advise people to do. Just draw yourselves an angle. A is in the middle. Then I have A to C. Maybe I can say A to N and A to C. Let them face away or let them face towards. That's the only way you can find this angle. Because what you need to do is, in order for you to calculate this angle, you will have to do a few things. You need to find the magnitude of AN, and then we have to find the magnitude of AC, okay? And then we have to take the dot product of the two. Then we'll be taking the dot product of AC dotted with a AN and AC. Doesn't really matter. Let's just write it in that order. The dot product of AN and AC. This is everything that we need to do. Right. So what is AN? If you look at AN from what we have over here, AN was 3i plus 6j plus 7k. 3i plus 6j plus 7k. So AN, which was 3i plus, what is it, 6j, okay, was it minus 3i plus 7k. Let's just go make sure. Minus 3i plus 6j plus 7k. That is what AN was. What is the other one that we know? The other one that we know was AC from our answer over here. So AC was minus 12i plus 8j, right? I'm just going to write that one over here. AC was, what was AC? It was minus 12i minus 12i plus 8j, maybe plus 0k. I can do that. Right, so we use Pythagoras to find the magnitude. So what we have is AN is going to be negative 3, but I'm just going to, I can write negative 3, but ideally sometimes not necessary to write that negative, plus 6 square plus 7 square. Take the square root of that. Okay, what is that going to give you? Well, that's going to give you the square root of 94. Then we do AC as well. AC will be the square root of, AC is here, minus 12, put it in brackets, squared, or you don't have to put a negative. But if you do put a negative, then you're going to put that in brackets, plus 8 square plus 0 square, and this is going to give you the square root of 208. So I have the magnitudes now. So now I'm going to calculate the dot product. To find the dot product, I'm just going to write my A and my I, J, and K in terms of column vectors. I find it a little bit easier. So this is minus 3 Okay, that's AN. This is minus 367. Minus 367. Dotted with AC. What was AC? AC was minus 12I. So it's minus 12 here. And this is 8. And that's 0. So we're going to do the dot product. The dot product is really straightforward. You just take the negative 3, the components, multiply together, and then you add x components. Now you take the y components, that is 6 times 8, plus the z components, that is 7 times 0. And that answer, whatever that answer is, in this case, it is 84. Here's something that I need to explain to you. Whenever your dot product is a positive number, okay, whenever your dot product is a positive number, your angle will be acute. Very important. Whenever your dot product is a negative number, your angle will be obtuse. When your dot product is 0, your angle will be 90 degrees. Okay? So in this case, I'm expecting an acute angle. So the formula that you use is cos theta is equal to that dot product. In this case, I can say A dotted with B, and then the magnitude of A times the magnitude of B. So you do find this in your formula sheet, I believe. So in this case, I'm going to say that the angle, the cosine of angle NAC will be 84, because that's the angle we're looking for, right? NAC, that will be 84 times the square root of 94 times the square root of 208. Okay, square root of 94 times the square root of 208. So the angle NAC therefore will be the inverse cos of whatever that answer is, which you get as 0.600, so on and so on. Okay, and then that will give you that angle NAC will equal to 53.077 and so on degrees. Then to 1 decimal place, the angle is 53.1 degrees. Okay. So that is the solution. Okay, so quite a lot of things that you need to do, and they were actually guiding you in this question for you to find A and then AC, because you will be using the dot product of A and AC. But if you are finding an angle, then this is what you need to do, and that is the only way you can calculate that angle. Right, that brings me to question 11. Question 11 is the second, or there's still more questions to go. All right, so we need to have a move on. The diagram shows a door which comprises of a rectangle and a semicircle. Then we can see the diameter of the semicircle is equal to the width of the rectangle. So that this is going to be 2r, this distance over here. This is going to be h from here to there. This length of this semicircle, the circumference of a circle, is 2 pi r. The circumference of a semicircle will be 2 pi r divided by 2. So in this case, it is just going to be pi r. So this is going to be pi r from there all the way up to there. The reason I'm doing that is that we are told that the perimeter, if I can find the door, it comprises of that, the radius of its r and so on. We are told that the perimeter of the door is 9 meters. So using everything that I have done, I will say plus the whole distance around, it's h plus h, that is h plus 2r plus that curve part, pi r should equal to 9. That is the perimeter when you add everything around that door. Okay, and then you want us to express h in terms of r, so 2h plus 2r plus pi r is equal to 9. So what they look for is h must be the subject of the formula. First, 2h is equal to 9 minus 2r minus pi r. Then h is going to be 9 minus 2r minus pi r, everything over 2. That is, we express h in terms of r. Okay. Then we are now told to find the area of the door. So to find the area of the door, okay, if you need to find the area of the door, you will have to probably consider that this part here in yellow, this area would be, this area is a rectangle, it will be 2r times h. That's that area in yellow. Then the area in green, which is this, right? That is an area of a semicircle, so that is going to be a half pi r square. So our job is just to find the area of the door, which is these two added together. So it's 2rh, so the area will be very interesting, 2rh plus a half pi r square. That's the area. Good. So now they say show that the area is equal to that. So what is it that we know? We have the following. We have the height from our answer before. And we know that the height is equal to this whole distance over here. 9 minus 2r minus pi r over 2. So that's 9 minus 2r minus pi r, everything over 2. Okay? Right, so let's see. If you, obviously the 2's will cancel. In many ways you can solve this. These 2 cancel with that 2. And that is going to leave you with 9r, or r, 9 minus 2r minus pi r plus a half of pi r squared. So let's distribute, okay? That is 9r minus 2r squared minus pi r squared plus a half of pi r squared. These two last terms, they are like terms. So at the end of the day, the area therefore is equal to 9r minus 2r squared. A half minus 1 is negative a half. So it's negative a half pi r squared. And this is what we needed to prove over here, like they were asking us to do. That is exactly this answer. Okay. So we have now completed that. So they are saying, given that r can vary, find the value of r for which the area of the door is a maximum. This happens when dy dx is equal to 0. But we are not working in terms of dy dx. We are using dy dr is equal to 0 because the formula for the area is in terms of r. So we are going to do the gradient. So that means dy dr, 9r is just going to be 9, the derivative of 9. differentiate this is going to be minus 4r. Then this is a half times 2, which is 1. So this is going to be minus pi r. This is the gradient formula. Now what is it that we need to do? We need to find the value of r. Okay, they didn't ask us to find the answer of the area of the dot, so there's no need for you to calculate the area of the dot. So therefore 9 minus 4r minus pi r is equal to 0. Your answer should be left in terms of pi. Okay, and what you can do is you can say, okay, 9 equals to 4r plus pi r. I want to work with the positive stuff of pi. Okay, then I'll factor out, take out the r, then I have 4 plus pi, and this is equals to 9. Eventually r will equal to this 9 all over 4 plus pi. Okay, that is what they ask us to do. They say you leave your answer in terms of pi. My answer has got a pi in it. All right, question 12. Show that the equation 3 cot x minus 2 sine x is equal to 0 can be written in that form. So 3 cot is actually the same of cos x over sine x minus 2 sine x is equal to 0. Then this is 3 cos x, and this is really important that you should understand this concept, because this concept is going to assist us quite well in calculating and finding this answer. I'm going to multiply throughout by sine x, so multiplying this term by sine x. So I'm just going to see if I can just remove those brackets, since I now have really wasted a lot of space there. So if you multiply here by sine x, this cancel. If you multiply this one by sine x, and also if you multiply here by sine x, I'm going to be left with 3 cos x minus 2 sine square x is equal to 0. All right, then if you remember from your identity, sine square x plus cos square x is identical to 1, then sine square x is going to be 1 minus cos square x. So this is going to be replacing this over there. Okay, so at the end of the day I have 3 cos x minus 2, and then I have got 1 minus cos square x, which equals to 0. Right, so now I'm really running out of space, and I'm just going to continue just here. So this is going to give me eventually, if you multiply out, you're going to have negative 2 times negative, that is positive 2 cos square x, and then minus 2, that is going to be minus 2, are you with me, and then plus 3 cos x is equal to 0. And we can just rewrite it so it can be rewritten in this form, because they're actually exactly the same. So therefore, from here I will say therefore, maybe even therefore, this whole answer is nothing but 2 cos square x plus 3 cos x, right, minus 2. So basically we have already expressed that in that form. Now they ask us to solve the equation. So we're not going to write this equation because this equation is exactly identical to that equation. So we're going to say this is nothing but 2 cos square x plus 3 cos x minus 2 is equal to 0. Right, the calculator should be in radian mode, so this should factorize. and this factorizes 2 cos x outside the bracket. I have cos x plus 2 minus 1, then it's cos x plus 2 is equal to 0. See if how much space I have to work with. All right. So then I have 2 cos x minus 1 or cos x plus 2 is equal to 0. Here, this is cos x is equal to 1 over 2 or cos x is equal to negative 2, which we're not going to use because cosine function oscillates between 1 and negative 1, so this will not exist. In which quadrant is cosine positive? Cosine is positive in, because it's from 0 to pi, it's positive in the first quadrant and in the fourth quadrant. So what is our angle going to be? So if that is 90 degrees, diagram is not to scale. This is pi over 3, that is 1, that is 2. This is pi over 6, this is like that is like 60 degrees, and that is 1 is 30 degrees. Right, and this is going to be root 3. So what is this? You obviously you can use your calculator. X will be cosine is 1 over 2, x is nothing but pi over 3. So this is the angle that we are looking for. Okay, so it's our acute angle. So in the first quadrant, which is over here, that's what that angle will be. And then in the next quadrant, we have to go. So this is in the first quadrant. So in the first quadrant, our x is equal to pi over 3, no problem. But then in the fourth quadrant, our x would be, it will be all the way from here, all the way up to there. So that is like saying you're going around 2 pi radians minus our reference angle. Okay, and if you do this, you are going to get that x equals to, that's 6 pi minus 1 pi, that is 5 pi over 3. So the two solutions are therefore x equals to pi over 3 or x equals to 5 pi over 3. Now all of these are in radians, so you can definitely also give your answer then as decimals. It doesn't really matter. And if you do give your answer as decimals, then you should give your answers to 3 significant figures. So what I will say is that someone can say x is equal to 1.05 radians, or x is equal to 5.24 radians whenever you are rounding that, when you calculate that with your calculator. Right, question 13. So I'll just quickly go back and just leave it there so you can just quickly see what is it that we did over there. So let's get to question 13. Question 13. A curve is such that dy dx is equal to ax plus 3, where a is a constant. The curve passes through the point B, which is the point 3, negative 14. The gradient of the normal of the curve is at B is 1 over 9. So this means that the gradient of the tangent should equal to negative 9, because 1 over 9 times negative 9 gives you negative 1. Gradient of the tangent and the gradient of the normal, their product is equal to negative 9. Why is that negative 9 interesting? Because where the tangent line touches the curve, their gradients are equal. So ax plus 3 is equal to negative 9. Okay? Then they say find the value of the constant a. What else do we know? We have got this x value of b here that we are going to substitute over here. Okay? Because that point is also on the curve, right? Passes through, so it's on the curve. So that is a times 3 plus 3 is equal to negative 9. So this is 3a equals to negative 6. Okay, then is it My God. Let's just do that. 3a is equal to negative 9 minus 3. 3a is equal to negative 12. There we go. Okay. Then a is equal to negative 6. That is the negative 6. Goodness. Okay. It's negative 4. That would be if you are dividing negative 12 by 3. They are saying you must find the equation of the curve. What is the equation? What is the curve now? What is the derivative of the curve? dy dx, dy dx. So just quickly write that one. dy dx now is equal to, we know what a is, so it's negative 4x plus 3. That is the derivative. Okay. Now, how do you find the equation of the curve? You have to do the antiderivative. So to find the equation of the curve, you have to integrate negative 4x plus 3. That's what you need to do with respect to x. Another thing, we are given point B. So let's see what point B is. It's 3 comma negative 14. And the reason I have that point B, 3 comma negative 14, I'll be substituting it because when I integrate, I will have a constant of integration and I need to find out C. So let's quickly integrate then. So y then is equal to integrating, this is adding 1 to the power, that is 4x squared over 2. So remember that is a negative 4. So that's negative over 2 plus 3x, all right, plus c, which is the constant of integration. So this is y is equal to negative 2x squared plus 3x plus c. And in order for me to find the value of c, I need to substitute 4x and 4y into my equation, right? Into this equation, right? So substituting those points, y being negative 14 equals to negative 2 times x being 3 squared plus 3, x being 3, give you the c value. This will give you c to equal to negative 5. And you can go ahead and actually look at it, right? Therefore, the value of y will, the equation now is complete. It's y is equal to minus 2x squared plus 3x minus 5. That's what the equation is, right? So when you need to find the equation of the curve and you're given the gradient, you do antiderivative and is the integral of that, and then you'll have a plus c because it's definite indefinite integral, and then you have to substitute a point which is on the curve, and we're given the point 3 comma negative 14. Okay, then we have question 14. Question 14 say the diagram shows the line y equals to 4 and the curve x squared minus 4x plus 7. The two graphs, they intersect at the points P and Q. Find the shaded region. Now I'm going to do this into two ways. I'm first going to say, let us look at the rectangle there. So the area of the rectangle is equal to this being 2 times 4, because from there to there is 4. So it is 4 times 2, which is 8 units squared. Okay, then I will look at the area of the curve. Now, what is the area of the curve? The area of the curve, we are going to integrate. That is what integration allows us. The area of curve is area under the graph, right? So area of the rectangle, then I find the area, okay, under the curve in this particular case. Now what I'm going to do with the two to find the shaded region. So what I'm now calculating here is the area under the curve from 1 to 3. So I'm calculating what is that function? That function is x squared minus 4x plus 7, integrating x squared minus 4x plus 7 dx from 1 up to 3. From 1 up to 3. That's the area of the curve, under the curve. So in a nutshell, if I have to highlight it, this is the area that I'm now calculating. Okay, this is the area that I'm calculating, what I'm now doing here at this one. The area of the rectangle is the whole thing there. So if you guess right, I'll be taking the area of the rectangle minus this yellow part, and that is what I'm going to do. So let's integrate to find this area. This is going to be, we can integrate quite easily. Add 1 to the power, divide by the new power, minus 4x squared. Okay, 1 is to close. Just put it over there. Over 2 plus 7x, and we're going to integrate from 1 up to 3. Definite integral. Right, so let me just write down what this is. This is x cubed over 3 minus 2x squared plus 7x, and we are going to integrate from 1 up to 3. Just had to clean it up a bit. Right, so at this moment, substituting the upper limit of integration, that is going to be 3 cubed over 3 minus 2 times 3 squared, I'm using this one now, plus 7 times 3. All right, I have done the upper limit. Now I'm going to do the lower limit, and that is going to be 1 cubed over 3 minus 2 times 1 squared plus 7 times 1. Okay, right, so if you do that, this is going to be 12 over here, and all of this stuff on this side would be 16 over 3. And if you subtract these two, this would give you 20 over 3 units squared. So that is the area under the graph, that yellow part. So the shaded region, so therefore, if you calculate the shaded region, so the shaded region will be the area of the rectangle, which is 8, minus the shaded below the curve, minus 20 over 3. Okay, all of this is square, unit squared. This answer, if you do it, you'll get 4 over 3 units squared, which you can leave as 1 and 1 over 3, but that is our answer. Okay, so there are many ways you could do it. There are many other ways. I chose to look at the rectangle minus the area below the curve, take the two, subtract them. That gives me the shaded region. So this brings me to the end of this paper. It took me quite some time, but I'm going to upload the paper 2s of the other years, 2023, 2022, and 2021. So be on standby for those ones as well. Right, so to take you then to the channel, as you can see, I'm uploading these days only the question papers for AS. I did all of the 4 paper 2s that are there from the national examinations. Then I also did commerce paper 2s and so on. So please do subscribe to the channel. Let's get the subscriber total to 10,000. Okay, and we can then, if the more you subscribe, then the more content I will upload.